हमारे बहुत we have relations developed 10 years ago, 15 years ago. So yeah, we are still working on the same channel. This is okay, you are working with the same channel, but this channel will not take you along for a longer time. You need to come back to technology. Today what the world you are carrying, you are carrying the entire world in this your mobile phone. So you have to come up in the mobile phone of your customers, of your traders. We all are connected with the help of technology. Unless until you think about technology seriously, you will not able to achieve that progress. The third component of sustainability of triple bottom approach is people. Many employees have laid off from work during COVID. Many were affected with COVID, and many families have suffered also. So again, if you see future, in future, the employees also want the organization to be technology friendly. Unfortunately, SME section in India is not that much technology friendly. So people face difficulty while working from virtual location. So because all the processes are not technically sound. So there again, if you will bring technology in your different processes, it will help you. It will help your employees to upgrade. It will be a good initiative for your labor force. I've just written a paper, and in the paper I've also discussed about that during COVID, the triple bottom approach has been shrink to double bottom approach. The organizations, the SMEs or either big multinationals, they are not looking after profit much. In this COVID period, the organizations are looking for their survival. Survival is very difficult. So with if you do not have survival, how you will how you will progress. And survival is only the survival is only possible if you know how to use that technology in your different processes. Let me share one or two my research with you all. Ma'am, can I share my screen? 1 minute. Give me a minute. Okay. Is it visible to all? Okay, so this is my work on SMEs. If you see, like my first paper, which has been published last year, technology adoption, a solution for SMEs to overcome problem during COVID-19, is published in 2020. Already got 27 citation. So if I go back to this paper, and also is in SSR, and have more than 2300 downloads. What I have discussed in this paper, again I have go back to the same thing. But what are the problems? The problems area for SMEs, like layoff of employees during COVID, health issues of employees, fall in sales, financial crunch, lack of customers demand. So these are the issues of not only of Indian SMEs, these are the issues all around the world. And if we are looking as for a solution, and that solution will also take SMEs towards sustainability, we have different types of technology, like talking about technology 4.0, in which we are talking about different components, like artificial intelligence, we're talking about robotics, we're talking about IoT. So you need to think about adoption of those tools. Another is social media tools. No doubt social media will improve your marketing, it will improve your visibility as well. Then you need to think about e-commerce channels. So that's how the role of technology in solving problems faced by SMEs. Here are the number of authors who have already commented on a role of technology, and are the key findings. There are other papers as well, which are talking about, like, this is social media tools for business growth of SMEs. This one, how adoption of online resources can help SMEs. Let me show you how many of SMEs went cashless during this COVID. In this paper, I have shown one diagram. There's a, like, this was the scenario last year when we were writing this paper in, like, July. More than 6 months of cash. How many SMEs have more than 6 months of cash? Only 6%. Less than a month of cash, 27% have less than a month of cash. 1 to 3%, 20% SMEs. Between 3 to 6 months, 23%. So they already are facing a severe problem. Indian MSME sector already facing severe hit because of demonetization and GST, and after that this COVID thing. So how you will be answer to this COVID scenario, which has not been over yet. At the same time, you need to compete with big multinationals. You need to make your own place in the market. How you can make that place in the market? No, you cannot if you will not think about technology. And that technology you need to think in not only just like, okay, we have our website and we can go ahead with that website. No, it will not work like this. You need to think about technology in effective manner. The problem is in the implementation phase, problem in the operation phase. How to adopt that technology in different your operations, in your either you talk about in your marketing, you talk about in your supply chain, you talk about even in your financial things. How to adopt that? The challenge is here. Everyone knows about technology, but when I talk to SMEs owner, they say implementation or adoption is difficult. Owners know, and they have the entire control of the technology, but they don't want to tell it to their employees. because there will be training cost involved. So you need to think about obviously, okay, initially there will be some costing, but in the longer term, the adoption of technology take you towards sustainability, and that's what it is needed. It is the it is the need of the hour, that we need to make our processes sustainable. Nowadays, people, big multinationals are talking about industry 5.0, and our SMEs owner don't even know the owners or employees are not even efficient on the components of technology 2.0. So there is a big gap which you need to identify and which you need to fill. Then only we can talk about sustainability. Then only we can achieve that sustainability. Thank you very much.
Thank you, sir. Thank you for your informative speech in this session. We got an idea about sustainable goals, SMEs, Industry 4.0, 5.0, etc. We gained a lot of information about SMEs and marketing, which is very necessary in this globalization. Thanks for taking time out of your busy schedule, sir. Thank you so much.
Thank you, ma'am.
Now the floor is open for discussion with Anuj Kumar, sir. Anybody wants to ask something? If you are having any doubt, you can ask now. Over to Nazia, ma'am.
Thank you, sir. Thank you so much. Nasrin, ma'am?
Yes, ma'am.
So now we have another invited talk at 10:45.
Okay, ma'am.
Now it will be having a tea break time.
Okay, ma'am.
Yeah, we will join at 10:45.
Okay, ma'am.
Sir,
Thank you, everyone.
sir. Thank you, sir. Thank you so much for joining us.
Thank you very much, everyone.
you can see the anti-allergic, anti-diabetic, anti-obesity, anti-cancer, and source of vitamin B also increases immunological response, lactose metabolism, and cholesterol normalization, blood pressure reduction, etc. All these things are present. And oral consumption you can do, localized application you can do, just like a medicine type of things. In a microorganisms you can reduce the harmful bacteria by giving the beneficial bacteria, and the growth of the beneficial bacteria increases. Then there is a nutrient competition. In that nutrient competition, it may be eliminated, harmful bacteria may be eliminated. In the cancer treatment, these are the delivery systems they are using it. And the general tumor, in that general tumor also, if you give a probiotic things, they work in the cytotoxic activity increase, survival rate increase, tumor progression reduction, angiogenesis reduction, mitochondrial apoptosis increase, tumor specific immunology. Like that, you can see as the research is going on, the new things are coming up into the picture. That's why if a friendly bacteria and harmful bacteria, the balance should be there. It is approximately in your body 1.3 kg of the bacteria side, you have a disease, or if a friendly bacteria side, your LB is increasing. And in general, if a human body is 100 trillion cells, and the 10 trillion cells are present in your bacterial population. And now I will go to the specific research oriented topic. This is one of my research area. Where is the external application of the glucans? And glucans is nothing but a carbohydrate. It is just like a cellulose, or you can call it as a starch or any other thing. But there is a difference between the glucan and a starch or a cellulose or common food material which we use it. In this, the two glucose molecules are attached. In starch itself is a glucose molecules are attached, n number of glucose molecules attached, and cellulose also n number. The difference between the starch and cellulose is the attachment between the two glucose molecules. In case of the starch, 1,4 linkages are there, 1,6 linkages are there. And in case of the cellulose, only 1,4 linkages, but it is a long chain. Then there is a difference in this. That's why if the long chain is there, it is not water soluble. If the short chain is there, it is a water soluble. However, in the glucan case also, there is two types of interactions. One is the linkage between the two is nothing but a alpha-1,3 linkages. Linkages is nothing but a 1,3 linkages. In 1,3 linkages also, alpha position type of linkages are there, beta position of linkages are there. And this alpha-1,3 linkages makes them very specific in their properties. If alpha linkage is there, properties are different. Beta linkages are there if the properties are different. And this is present in the microbial cell walls. And alpha glucans and beta glucans, pharmacological important, I will tell you. And dextran is an antiplatelet. We talk about the platelet count and all these things. It is nothing but alpha-1,6 glucan. It is an antiplatelet property it has. Glycogen, it is a food reserve. It has alpha-1,4 and alpha-1,6 glucan. Polyulan, it is nothing but edible films in breath freshener. It is a 1,4 and 1,6 glucan. Starch, which we are talking about, alpha-1,4 and alpha-1,6 glucan. It is a thickening agent and paper making industry they use. Specifically, if you go to the beta glucan, cellulose is beta-1,4. It works in paper glucan. Cordylan is a gelling agent. Lecithin is an anti-cancer agent. It is nothing but two glucose molecules or different glucose molecules are attached with beta-1,3 and beta-1,4. Zymogen is immunomodulating and it is beta 1,3 glucan. So now you can see the linkages between the two molecules or glucose molecules among the glucose molecules are making the different combination of the carbohydrate which have a different property. And these properties again differ with the one is a bonding nature, another is a length of the chain. And rare glucans also we can see muton 1,3 glucan. It is immunomodulating. Alternon 1,3,1,6, Retron 1,4 glucan, and this is again chain length and branch nature. Laminar, lentinon, pluron, and beta glucans are water soluble, and alpha glucans are water insoluble. And if you see it, these glucans are non-allergic in nature. Any foreign body comes into the body, they are allergic and causes a lot of problem into the immunosystems. And health benefits, if you do soluble fibers, whatever the fiber is nothing but again this one, helps in LDL absorption, non-digestible, pass through the intestine and works as a prebiotic, binds to lipids, fats, bile acids and toxins, help to sweep away from body all these toxic elements. Again prebiotic effect. Absorb water, cleans the stomach, it is again prebiotic effect. Increases the vicinity in the digestive tract, maintains the energy levels, prebiotic effect. And lowers LDL triglyceride, reduces the chance of stroke, acts as a stimulator to the immune system, expands by O2 absorption, reduces the appetite, then obesity reduction, and even diabetic control. Moderate the glucose levels, controls the diabetics, binds to the macrophage receptors, reduces the chances of cancer, digested by colon bacteria, reduce the risk of the colon cancer. In addition, fibrinolysis, and that means is nothing but a heart diseases related reduction, anti-inflammatory, prevention of infection, septic shock, surgery, wound healing also it will help in the proper holding and this one. So this is the way of production we followed. We have taken the microbial system, grown in the fermenter and taken that one and isolated the glucose in the system. And this different microorganisms produces the different type of, we have 6 type of glucans we have isolated, and each one is different. And it's functional, whether it is a glucan or not, we have checked by the IR. IR is a 930, you have a peak in the IR. If the 930 peak is there, alpha 1,3 linkages. And the red color is the actual glucan. And since it is a non-soluble in water, insoluble, hence we have made it a water soluble by functionalization. After functionalization also we have checked the IR and it is giving a 930, that means alpha 1,3 linkages are there, hence we. And glucose, whether it is a muton or not, so glucan or not itself. Glucan is a glucose binded molecule, glucose polymer. And glucose polymer can be anything. And if glucose can be checked it by the DNS method or whatever is another method, but if this is a bosogenic method is there is a specifically the DNS method or that method will give the all reducing sugars, whereas in the glucose, specific glucose bosogene test is there. Bosogene test, you find the glucose molecule as needles under microscope after breakdown of it. Hence we have found that this is a glucose related. And the beta glucans in gender, whatever it gives, the 5 immune responses it gives, beta glucans. White blood cell production, cellular mobilization, phagocytic capacity, reductive oxygen intermediate production, and stimulates the TH2, TH1 cell mediated immune responses. And we looked at the antibiotic activity. Both glucans, sulfate glucans has not given since it is not water soluble, whereas sulfated glucan or a functionalized glucan, it is giving the antibiotic effect. and it is similar to the control of the streptomycin. And control we have taken this one, and this is we have also looked at anti-inflammatory effect using against the diclofenac sodium as the inflammatory agent, and it is almost all sulfated glucans are giving a with increasing dose increasing effect. And if it is a really sulfated glucan is giving, the gelling portion will become a liquidy, that is called nothing but inflammatory things. And we looked at the cancer cell inhibition also. Sulfated glucans are not effective much, and IC50 values, if you see, if the different cancer cells, different effect is there. And we have looked at the breast cancer cells, breast metastatic cancer cells, liver cancer cell lines we have used here. And the glucans or anti-cancer properties of these glucans can be taken from the different mushrooms also. That why mushrooms is very good for the health. And you can say the inflammation and how the chronological reduction of this one takes place in the inflammation case, remodeling and the cells and everything. And wound healing activity also we checked. You can see the standard. Whereas if you apply glucan, nothing is improved. But if you see sulfated glucan or functionalized glucan, again the wound is reduced a lot within a 1 week or 2 weeks. And even a sustained release also we find it nowadays is a liposomal sustained release also is a one major thing. Even if you take most of the diabetic patients now are taking a sustained release drugs, and that sustained release makes them to release slowly over a 24 hours or over 12 hours or whatever it may be. And in this also we made it a gelling agent with this glucan, and then looked at the different time intervals, what is the second day, third day, how it is affecting. And this is microorganisms we have used. We can see the 100% growth is this one, and the third day also there is a reduction of the growth is taking place. That means sustained release is possible with this. And you take the probiotic formula and future is with you. If the future is your infant, either it is infant or children or adult, one is necessary. And entire thing can be with a simple microbial population. What type of microbial population is giving which effect is given. Though there is a lactobacillus and bifidobacteria, we talked about things. In the lactobacillus also there is a strain specific effect is formed. Epigenetic changes are there, lactobacillus ruminances, and it works in the liver and gallbladder. Where skin and other cancers, you can take immunomodulatory effect is there, again raminosus, but it is a GG, another different strain. And potentiates the drug activity lactobacillus casei, bladder and prostate cancer. Suppresses the cancer because of bifidobacteria in cervical cancer. Like that, each strain will have a specific, even a breast cancer, head and neck cancer, and blood cancer also reduction can be possible with the probiotic specific strain. And this is a chronological path started. It is the probiotic nature and health and in the system, and probiotic and prebiotic, and there is a research is going, and the society is involved, clinical application is involved, and which is again a complicated subject. And this probiotic nature or prebiotic nature came very recently. This is 2 decades or 3 decades back only started, and so far the probiotics, our understanding is very less. That's what we say, that a baby recognizes its mother but doesn't know simple mathematical solution 1 + 1. However, baby recognizes the mommy. We are also recognizing the probiotic effect on the human health, but we don't know the clear benefits of the things. So a person can think of the future in this way. It is possible to make it in such a way. So probiotics are going to make it such a way. And this is from my group. And thank you very much for the listening, patient listening. Hello.
Thank you, sir. Thank you for the enlightening presentation. We are very grateful to have you here with us, sir. That was a very informative session about probiotics, prebiotics, and postbiotics, and also microbial organisms, health benefits of glucons. I hope this presentation would have exposed our participants towards tremendous knowledge. I thank you once again from the bottom of my heart for taking time from your busy schedule. Thank you, sir.
Okay.
Now,
Anything?
now the floor is open for discussion with Dr. R.S. Prakasham, sir.
Hello, sir.
Hello.
Sir, the talk was really highly informative, sir. It has gone from the basic to the till whatever is there. It was really nice. I was enjoying each and every slide. Sir, I have one question, sir.
Please.
How can probiotics be used to control the increase of antibiotic resistance, sir?
See, what is happening is that probiotics are energy regulators. What is the levels of the glucose levels increasing is nothing but a diabetes. One. Or this may be because of the beta cell dysfunctioning, or any other increasing the blood, whatever the other factors. Even if you go to the doctor, a diabetic patient is there, they first ask you to take the metformin or some other medicine along with the mineral sources with you, vitamins and minerals. These minerals and vitamins helps in the absorption of the glucose from the bloodstream to the cells. And when the bloodstream glucose is reduced, diabetes is reduced. So this probiotics, one way it helps in the absorption of the minerals, I already told you in my presentation. So that is the one way. Second thing is that part of the glucose can be used by the blood glucose is included by the probiotic microorganisms. When these two factors or three other factors are increasing, the reduction of the glucose levels in the blood is reduced. That is nothing but a diabetic medicine reduction. Did you get my point?
Yes, sir. I got it, sir. Thank you, sir. Thank you so much.
Welcome.
Good morning, Professor.
Good morning. How are you?
Fine, Professor. Next presentation,
I've
Professor.
seen your address as a botany professor.
Yes. The probiotic in cancer treatment difference between alpha and beta glucans on the rare glucans and the health benefits. And one more thing, sir, the valuable contents are with each and every slide. Thank you, Professor. Thank you, Professor.
Hello. Is anyone is having any questions? Now it's a flow for making interaction with our eminent scientist. I think, sir, no one is there.
Okay.
Thank you, sir. Thank you so much. Yeah, yes, sir. Yes.
So I can wind off?
Yes, sir. Yes, sir.
Thank you.
Thank you, sir.
Thank you once more for your nice invitation and for the giving the opportunity to interact with you.
Our pleasure, sir. Our pleasure. Nasreen, ma'am?
Yes, ma'am.
We'll wait for 5 minutes.
Yes, ma'am.
Yeah, for our next speaker.
Okay, ma'am.
here, and my voice is okay. Okay, good. So now we start my lecture. So now again, thanks to organizing committee and team of this conference. They have given chance to me to present here. So today my talk is based on factors and chaos in engineering and sciences. So a lot of things already have been done in this conference from the last 3 days. Now this is the last lecture of this conference. So today I have some more new things, factors and chaos, and I will present how to study some problem in engineering and sciences. But before that, I will present you what is the chaos, what is the factor, and I will show you today a many beautiful and complex things inside the chaos and fractal. It means we have these things, latest thing in the mathematical sciences, and we see the applications in engineering and science. So just I now continue here this one. So I will speak on this. This talk is aimed to explore fractals and chaos in engineering sciences. Several research works are currently associated to fractals and chaos. Chaos exists everywhere in the world since most of problems are non-linear in nature. Chaos can be easily visualized using fractals. The demonstration of some mathematical models associated to fractals and chaos with their application are presented here. This presentation may attract mathematicians, scientists, and engineers toward fractals and chaos from their different research fields. So now we start this with a quotation of Albert Einstein. So imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world. So stimulating progress, giving birth to evolution. So every time whenever we speak about scientific things or engineering or technology, we must have to think about that. And what will come new about that, we have to imagine. First we imagine, then we can write as a model, and we can simplify, we can do the simulation using existing theories. And sometimes existing theory will not work, then it is a chance to make some new theory or develop a theory, and we do the things, then we say we can get a progress. Okay, so now we have one more thing is there. Now recently we can say that innovation in technology have been, the scientific tools have been developed by advanced mathematical techniques. So whenever any kind of tool, we have the development, most of development around the simulation, computation, numerical science, any kind of this type of things related to, we can say, mathematical things. And now we say that advanced mathematical things, because we say that fractal and chaos theory are all of that. So these theory are advanced and new things. So we say these advanced mathematical techniques we apply to solve the complex and difficult problems. So question is how to see and what are the fractals and what is the chaos. So first we see these pictures. These pictures are fractal, but these are also complex pictures. Inside maybe there is chaotic behavior or maybe come after the chaos. So we see that here we have other kind of pictures. So these are our fractals, and most of these pictures generated through mathematical model, and these exist in the many engineering and scientific applications. I will show you this similar type of picture. So how these pictures are complex. So inside there is complexity, there is a difficult things to generate these pictures. So we have now like this, complexity in the system is due to non-linearity, irregularity, and roughness in the nature. We can find the solution of complex problem using fractals and chaos. So here is, we say first fractals, and what are the fractals? how do these appear in nature, and how are these useful in mathematical sciences. So first we see that what are the fractals. So now fractals are no and hard and fast definition of fractal. There is no fixed definition, but fractal can be defined in terms of characterization of things. So what are the characterization? Characterizations are, first is we say irregular shapes, shape similarities, fine structure, detail on arbitrarily small scale, fine structure, and also we have house of dimension strictly greater than its topological dimension. These are few of definition, maybe more characteristic we can find in the literature and we can extend. So now we can see the fractals like this according to definition and what we have shown in the beginning, the picture. So we can generate picture like this. Here is we can see what is the structure of the fractal. When you go cut and cut and cut inside this, we get picture like this in the triangle. I will show how to construct this picture. Another fine structure, this is a fine structure. It means when you go inside and inside, finally you get again similar picture. This. So this is another. So when we get three again similar kind of triangles. In each triangle, we cut like this. So we get new shape like this. Every time we delete the middle fourth triangle in the black. Do this again, we get like this. So in the continuation of same process, we get next one. Now we compute another snowflake curve, fractals. We have triangle again. In this triangle, what you do, again we do something new, not as before triangle, we do on the line. We have already done for the line, 1/3 you cut and 2 lines. Continue this process and again continue this process, you get last curve, that is snowflake curve. So this is one of the shape inside object, inside fractal. We have another kind of fractal object inside the fractal. So you can see carpet. Why is the name of carpet? Because we get a shape like carpet. How? We take a squares, one square, and then we cut 1/9 part. Why 1/9 part? Because we cut like this and this. Total we get 9 part and we remove 1/9 part. We remaining same size of 8 squares. In rest of it, we continue same process. Middle lines we cut and do like this. We get a last shape. That is a fractal. Okay, we say more fractal here. We can cut squares also another way. We remove 4, 1, 2, 3, 4. Again continue on the each flag and we get last. We may have different kind of shape initiator and we produce this new type of this structure. We replace on each small line same structure. Now we have Sriramapuram cube. This is also available in 3 dimensions. So we have cube and then we cut like this. Inside that we cut from all sides. In the middle we cut small cube and continue this process again on small cubes inside that and we get last one, this structure. So these structures are very useful and very popular in the science and engineering. Okay. So now we come on the next topic. I already told in this chaos. So chaos, when it is the chaos, we start with something where you know about this and you maybe listen in through media, or you have seen this in literature. Market prices are chaotic. Traffic situation is chaotic. Weather is chaotic. The behavior of human is very chaotic. Structure of brain is chaotic. Chemical reaction are chaotic. Explosion of volcano seems chaotic. So on. A lot of things we have seen in the literature. So today I will show you what is the chaos here as a mathematically or as a scientific. First scientifically, then rough definition, then is chaotic. Then we see this chaotic situation through mathematics. So chaos exists everywhere in the world because a lot of problems you have seen, and there is chaos word exists. So many more chaotic behavior we can see in scientific systems. Electrical circuits, mechanical oscillator, lasers, non-linear optical system, chemical reactions, nerve cells, heated fluids, heated hearts, cells, turbulence, and a lot of scientific application. We can see there is a chaotic behavior. Or maybe those who go through the scientific literature through many kind of different papers from different fields, they may see this word chaotic behavior inside. And if you those who are interested, just they type in Google Scholar or any database where we have a research paper, just type chaotic. You get many thousands papers. Not only 1,000, maybe you get papers in millions. Okay, so what is the chaos? One thing is this, because we have shown that many things about the chaos. But what is the chaos? First, we try to understand. Then we can study scientifically, and then we can apply in our study. So we will see this here. Extreme disorder, irregularity, and confusion in our system. This is a very rough definition. Extreme disorder, irregularity, and confusion. How to recognize first? Chaos. Then we can quantify. First, we must have an idea there will be chaos or not. There is something starting, and then we go inside and we check. Yes, there will be chaos or not. So extreme disorder or irregularity and confusion, then there may exist chaos. So chaos is like this. Chaos is a phenomenon. It is not a picture, it is not nothing, it is a phenomena, some situation that has a deterministic underlying rules behind irregular appearance. So there is extreme disorder, irregularity and confusion, then we can see that what is the situation there, and that situation we use the underlying rule, that is deterministic underlying rules behind irregular appearance. Then we may have chaos. So we can see that what is the chaos differ from other phenomena we see. We of chaotic and other phenomena. Type of phenomena, appearance and underlying rules. So if something is regular, appearance looks like regular, it is deterministic, there is not big thing nowadays. Something is statical, it is appear regular, but it is based on probability. Next is we have something random, it is irregular. Generally it is random, generally it is irregular, and it is based on probability. It is also based on probability. It means the two things based on probability are not very accurate 100%. If regular, then it is no need to prove. Okay, it may be determinate. But it is chaos, it is irregular, but it is determinate. It means if there is solution, you must have a solution. It is already irregular. It has advantage over all other phenomena. There is no standard definition of chaos. Again, feature of chaos. If you find the features like this, then there may be chaos. So it is deterministic, non-linear, irregular, and sensitive to initial conditions. When you find something as a last one sensitive to initial condition, that is very important inside the irregular and non-linear system, and it is deterministic. Anything you find, then you can try for chaos, and you try to quantify the chaos. So non-linearity and chaos. Sometimes you can say that this is highly related to non-linear. So some sudden and dramatic changes in non-linear system may give rise to chaotic behavior or chaos. Not all non-linear systems are chaotic, but some of them there is sudden and dramatic changes. Signature of chaos. How to identify the chaos through mathematically? This is the thing. Signature of chaos is divergence of nearby trajectory. So divergence we know in mathematically, and trajectories we know also. We choose two trajectories. It means two kind of sequence of the numbers, and after certain step they will diverge. It means distance between these two numbers will be go far away or not able to come close to each other. So now what happened many times, our system, most of time, not every, for all systems, most of time what we have, we write our difference, our system. When we try to model, we write in terms of differential and difference equation. Then we get dynamical system. I will show you things through here, dynamical system. Most of things in fractal and chaos comes through dynamical system. It is also exists through others. But nowadays, most of, whenever you find a research paper, mostly more than 90% papers associated to difference or differential equation and dynamical system related to chaos and fractals. And also dynamical system can be divided in two parts, linear and non-linear. But our interest in chaos. For linear system, fractal exists. There is no problem. I will show you some of fractal through linear system. And but most of, when we want to show chaos, system must be non-linear. And non-linear system again can be classified into discrete and continuous dynamical system. Same linear system also we can classify into discrete and continuous dynamical system. So here we will show fractals through linear system, some of the fractals through linear system, but most of things I will show through a non-linear system, and also these two may be either discrete or continuous, means either difference equation or differential. I will show you now the model. This is a rational model associated to three-dimensional non-linear system or differential equation. These three differential equations, and now we have this. We get this type of picture. This is a chaotic, and this is a fractal, and but it is a chaotic. Inside that, for certain parameter, we have chaotic. If you change your parameter, maybe for certain other parameters, maybe again chaotic, or something here in this system, you can change that something different, and you may get some different, because they use xz as a nonlinear parameter. You can choose different things here and calculate. So we have very famous model that is first given by Loring in 1963, but that time we don't know it is a fractal or it is a chaos, because that time we don't have the name as a fractal and chaos. But they say there is a very complex picture, there is a noisy picture, or some different name. This is another non-linear model. This is differential, three differential equations, and this is the Loring, famous for Loring fractal. Fractals. And inside that there is a chaotic behavior, very complex picture, a lot of things behind it. A lot of study behind this Lorentz system, Lorentz model have been done. In literature, maybe you can find many thousands or many thousand paper on this. And some of them I have gone through another paper similar than this. They have generated another model like dynamics of a generalized Lorentz like Q dynamical system. It is published in this year 2021, and they generalized the Lorentz like model. So they have changed this nonlinear system. They use some more terms, nonlinear model, and use something. So it looks like that, not exactly that. For that system, they studied the things. They have got these type of vectors. Inside that, we have now these shapes are just like a butterfly shapes, looks like that. Also, these are chaotic attractor, these are fractal. Now we come on next another kind of fractal. So we can connect this through population growth model, and we go for simple fractal. That is a first time studied in the through logistic map application. This is very good application in population model. So we studied a lot of population model through different way using different parameters. So suppose n1 is still proportional to n0, and they use another parameter b, and then we write n1 like this and calculate. Just iterate this n2, n3, and we get n plus 1. Then we use some different notation, and we construct xn as a variable. Then we put this thing in the previous, we multiply by b over a, and we put in the previous equation, we get like. So we get this model xn plus 1 is equal to a xn 1 minus. This is a very simple polynomial, second degree polynomial, and very simple function. But behind that, a lot of things. Also, we can extend to in complex variable. Then we have many more things. Many more. Actually, basically, when it is write as a complex number, write a second degree equation like z square plus c by transforming in some way, and then it is a rich model, and this is for that model first fractal has been generated by Mendel. I will tell you later. So now we see that what is how chaos and fractal involved in this system. Fx is equal to rx1 minus x. So we see that here we have this. If we change the parameter, then we can see that here this things is changing like this. This change is saying that introducing more cyclic system inside this. When increase the parameter, when we go near to 4, then we have chaotic situation. We can see through this diagram. In the beginning, we have this fixed point, then periodic point, then we get 4, then 8 and 16, then again like this. So root to chaos is periodic doubling. This is the basic thing. Root to chaos, periodic. So here is periodic doubling is going on. It is root to chaos. We can quantify this chaos. I will tell you later how to quantify this. But here we say that we have signature of chaos. Periodic point means fn x is equal to x or n equal to 2, 3, 4. So system of 3 different equations, we have another. Now I have shown this before 3 differential equations. Now we will see 3 difference equation like previous. We have shown 1 difference equation. Now we have 3 difference equations. In that case, when we choose some certain parameter, we get picture like this. She said. It is generated through this system for spatial parameter values. It is not a copy paste any image. It is generated image. Looks like a C shape. Okay, so we have another kind of model, that is a rotation model. In the rotation model, we have these 2 equations in 2 dimensions, in 2 variables. So theta is a rotation angle. Based on theta, we get when we find a structure of this through iterations, we get like. We do study the dynamical system of this. So a lot of things inside that. Inside that there are basins, there is security structure like that. So it is a fractal and squares, both things. Now first who has generated fractal? It is generated first fractal by Mendel Benoit V. Mandelbrot. He is now more. But around 1980, the Mandelbrot introduced computer graphics in his work related to complex dynamics. I already told these things related to this picture. I say zoom inside and inside, and you see how we can generate by this simple function z square plus c. I have already shown second degree polynomial, real polynomial ax1 minus x. When you open this and you can transform through, you can write like z square plus c if you go in complex. So that equation is a special case of this. So we can generate this fractal through C on C. We plot the C and we say Fn0 is 1. We get this. So we have also fractals in complex dynamics. We have in complex plane. That is called complex dynamics. So here stable set we say Fatu set and Julia set is we say chaotic set. And Fx Fatu set defined where family is normal. It means family is convergent. Julia said is just complement of Fatus. So both are complement, Julia and Fatus. So we can say that complex pair divide in two subsets in complex dynamics. We can see this through Newton method. We have a simple function zq minus 1. We operate this on the Newton function z minus fz over f dash z. We get this function. We can find a fixed point of this nz equal to z. We get 3 fixed points, but these 3 fixed points attract. It means we can show the attraction. It means we calculate a derivative of function and these fixed points and take a magnitude. If that is less than 1, then we say these are attracting. Simple calculation. And basin of attraction we can define like this. For all iteration, those go to fixed point as a attracting fixed point. So all set is become basin. So if those points go to 1, we say basin of 1. Then other fixed point we go to say basin of other fixed point. We can see this through what I told in the previous slide. If we have red region converts to 1. So it is basin of, red region is basin of 1. Green region converts to minus 1 plus 3i over 2. So green region is basin of minus 1 plus 3i over 2. And what is the basin of blue region? That is minus, what is the basin of minus 1 minus 3i over 2 fixed point, that is blue. Now we can see some more things in the complex dynamics. So recently we have published a paper in just in the 2 weeks before in a fractal and fractional journal, and fractals, as Julia said, a complex sine function via fixed point iteration. So we have chosen this function and we study the fractals for this for different parameters. We get this. These are fractals. Many more. Picture looks like very natural things. Looks like different shapes when we see around us, or we say many shapes in our decoration or many other things. Okay. So now we come on next, zeros of solution of linear differential equation of second order. We can see the application of that in differential equation. So we say take the second degree differential equation, second order differential equation, and we find a solution that is used, and this can be right in this form C1 root J is a Bessel function, and we calculate the ratio of that of Bessel functions, and then we calculate the fz. Z is minus uz over u dash z, and calculate Newton function for this. This is a Newton function. And we iterate at root 2. So black region does not converge, white region converge but need more iteration. Gray region means converge very fast. So we get this type of picture inside. we zoom it, first picture, we get like this. Again zoom it, we have. To see that inside we go for solution inside, and inside we get a picture like Mandelbrot, it is already fractal. So don't need to prove, just apply that theory and describe your solution. Julia said describe quantum tunneling in the presence of chaos. So both things here, fractal and chaos. So this is also applicable in this application of Julia set. So this is scientific engineering, either you say engineering or scientific application, whatever you say. We can see generate fractal through iterated function system. Above we have shown that many pictures, but for those pictures sometimes we need many more functions to construct that picture. I have shown in the beginning just pictures to show through geometrical. Divide like this, okay, again divide. But that is for theoretically or non-mathematician or non-scientist, it is good. You can say artist can generate picture through that. But how to scientifically, and how to apply this scientifically, and how to use scientist and engineer in their application. So we have now iterated function system to generate that. So in this iterated function system, we choose the construction mapping F1, F2, Fn, and we use the construction map Fz1 minus Fz2, norm less than equal to alpha, norm Z1 minus Z2. So we will see this here. What is that? How to construct? So for that we construct a affine transformation. These are linear equations we can write in terms of transformation Fxy, A, B, C, D in matrix Xy matrix plus Fex. And we can also write in these things in polar form if we need it. If sometimes we don't have direct numbers, we have polar form, no problem, we can use it. Okay, so now we choose the numbers. These are given theta phi in the polar form, rs theta phi. Construct a Basler form, very famous form. So we choose 4 maps F1, F2, F3, F4, and these are our construction maps, and we do the mapping of this. F1 converts to R1, F2 converts to R2, F3 converts gives the R3, F4 gives R. So we see like this. If we choose a something like this, initial, this is the initial is like a rectangle, and we apply this on the rectangle 4 shapes, these 4 mappings, and we get 4 shapes R1, R2, R3, R like this. Again we continue in all 4 shapes, in each shape all 4 mappings, we get second picture, and then finally on the 5th iteration, and we continue like this, we get leaf like this. So finally we converge our 4 mappings in iteration. This form, this is the Basler form. We have more things implementable. Fractal dental antenna for low invasive biomedical device. This is published in 2010, and in this paper a novel antenna is proposed for teeth implanting, which may attach a low invasive biomedical device to monitor human being health condition. So they apply the structure like this. So this structure you see in the all pictures, and above and down in also in 3 dimensions, looks like these are coming from fractal. Now we see some more things. Theories related to fractal and chaos are being applied to many biomedical areas. Included is the study of respiratory disorders such as Cheney stroke, respiration, and infant apnea. Also included is the study of feedback mechanism in the control of red, white blood cell concentration. Investigation, circum, rims, and cardiology and neurology. We see this here. So now application in biological science. So initial study in cardiology can be seen in this paper in 1983. And is the healthy, they have a lot of question in that paper, is the healthy heart chaotic or not? Goldberger et al. Presented convincing evidence that, at least in the case of ECG waveform, the healthy heart is a chaotic heart. So they say that if there is something chaotic, then heart is a healthy. If no chaos, then they say not healthy. So we will see this. Chaos and heart rate. The normal human heart rate fluctuates chaotic. Normal heart rate displays complex fluctuation in time in response to environmental factors, breathing, activity, posture, emotion, all of which are mediated by different feedback loops acting in parallel. So heart rate variability can be characterized in terms of scaling, fractals, and even multiplex. Because above characterization is above activities is associated to characterization of fractals and. So how is become common knowledge that variability is chaotic? Chaotic system displays sensitive to initial conditions. So that starting at two different nearby points leads to different time courses. So researchers have studied scale invariant property of human habit time series. In their studies, they sample bit to bit heart rate fluctuation over very long time intervals for different cases. They studied healthy subject awake and asleep, subject with heart failure. So what is that next? They say application of this analysis may lead to new diagnostic for patients at high risk of cardiac disease and sudden death. So no chaos in heart rate, no life. This is they concluded like this. So this is very interesting as a chaotic situation. Those who want to interest in this system to apply the chaotic. Now we have another kind of application, fluid duplets. So in this case they have to take this type of model and they study and then continue like that, and they try to generate a picture of through data. It is found there is region of large forcing that may exhibit chaotic motion of droplets. So they got picture like this. Inside that, I already shown that inside this type of application we have always chaotic situation. How to describe this through, how to say these are fractals and how we quantify, we use the fractal dimension. The fractal dimension are used to measure the complexity of object. No universal definition of fractal dimension exists, and several definitions of fractal dimension may lead to different results for same object. So shift similarity dimension, box counting dimension, half dimension, and estimating emitting dimension, and many. Self-summary dimension we have here, analytic tamping of mathematical. I already told this in the beginning. What is the self-same object? A set map up of m copies of itself scaled by scale r having dimension. This d equal to log m over log 1 over r. I already told how to construct Koch curve. In the Koch curve we scale 1 over 3, we get 4 copies. Same we get in the frequency triangles like that. Okay. So we have Cantor set. Cantor set is 1/3 we remove from a line, so we get this dimension. We have Koch curve, log 4 over log 3 because we have 4 copy and scale by 1 over 3. We have snowflake curve. We have also similar kind of things. We have same dimension. So many objects may have same dimension. So these are objects in fractal geometry. We have different name and different dimension. We have recently applied this fractal dimension on coastline of Australia, and this paper is published recently in Scientific Report, which is very famous journal of nature. So we have calculated coastline of Australia. Recently, just I forget to mention here, I published a paper on coastline of India. It is published in Geoscience. How to quantify the chaos? How to say there is a chaos? Picture is complex, but how to say there is a chaos? There are many definitions. We calculate chaos through Lyapunov exponent. If Lyapunov exponent is positive, then we have a chaos defined like that. So we can see this here now. We have above picture. We have shown that this bifurcation dilemma. Where is a black region? We have above picture. We say that is Lyapunov exponent. There is positive. Where is a negative above picture? We have wiped it. So there is no. We have published another paper similar like that to study the chaotic behavior. Published in abstract and applied analysis for this function, and we have similar kind of structure. We have chaotic. So I publish one more paper related to chaotic behavior, flexible assembly line of manufacturing system. It's a pure application. Is a pure application in manufacturing system. So we have found the behavior in a system. So I'll go a little fast to. So in this case, we have taken this system, how this system can part A arrive from here, part B arrives, and finally, when we have decision or when we build something through manufacturing system, either scrapped or after rebirth, something. Okay, our decision may be something good, don't need to do. So in this case, we apply this definition of Lyapunov exponent, and we find that chaotic behavior through this, and we have found this. Above is this separation graph. We see the two trajectories. So two trajectories is going on. A difference between two trajectories going on very zigzag. And then we plot the Lyapunov exponent. We have this. So this is a chaotic behavior. Now we have recently published this by this Julie Zhang in 2019. They show the novel 3D fractional order system. They have taken this fractional order system like this. Q is fractal. They have generated a picture for this system. We have fractals as well as Q are different values of Q. Now we see another kind of a sensitive dynamic mutual inscription system based on new one-dimension chaotic system. So they apply this chaotic system. They have generated xn plus 1 related to cos on sine this function, and they apply the inscription system. Now we have efficient numerical method in asking type their dynamics in pure mathematical application numerical analysis. We have application. Choosing this function, they have generated picture through different parameters. We have these beautiful pictures. Now we have another things here. Study of local convergent dynamics of King like two-step method with application, published in Mathematics 2020 by this several authors. In this, they study convergence line. In this convergence, they have something special, but now we don't have time, so don't want to explain much more. We have another kind of on dynamics or tri-parametric family. In fourth order multiple zero finder with weight function of principles mth root of function to function ratio. So this is a beautiful picture for this paper they study. Many more pictures they have. So now I want to stop here. These are the references. Those who are interested, mail or something for discussion, or they can ask anything, I will reply. So now we finish it. Also, this last slide is also for related to Einstein, because this is the home of the below picture is the home of the Einstein, original home is Einstein in Bern, Switzerland, and above is the museum. In the museum, he is the Einstein statue there, and behind this museum, I visited there in 2018. Okay, thank you very much.
Hello, sir. Hello.
Yes.
Hello, sir. Sir, what is the difference between differential equation and the differential equation, sir?
Yes, I already told. Actually, difference equation just simple. See this here. I already told, but again you see this here.
Sir, lot of diagrams are there. All diagrams how to draw, sir. Which software do you use?
Yes, yes. See this here. This is generated through differential equation. Clear? dx over dt. Okay. This is the derivative. But when we have a difference equation, it is like this: xt plus 1 xt. This is the difference equation. Understand?
Sir, no, sir. No, sir. What is the difference? Difference
Yes,
between
yes.
these
I
two?
saying difference is, see this. Direct difference. Okay, you see this here. I already construct a equation here.
No, sir. After getting, you are getting some diagram. After getting diagram, what is the difference? That's why I am telling, sir, in graphical representation.
No. After that, I don't know. It may be same or may not be same. Okay, picture become any kind of picture, but
Sir,
we have a
software?
system.
This kinetic system, which software was good, sir? Drawing graphical representation.
Yes, after drawing, we can quantify through mathematically. There are many definitions we can without drawing, but it is not easy. If we have a picture.
Sir, which software do you use, sir?
Any software, in any, okay, you write the program in any, but if you are interested, many program already available in all kinds of programming. Any MATLAB, Mathematica, Python, C, Fortran, any language you can use. Actually, there is no unique, because we write every time our program. Because there is no unique software. Few of them now people have generated for particular picture, but those will not for use for research purpose.
Sir,
for particular things you can do. For journal there is no software, but particular things you want to do fractals, so they may exist. But many of them may be costly.
Sir, one more question. The Lyapunov function, how to identify the function, sir? Sir, many of the equation is very...
Lyapunov function. Here is a Lyapunov exponent. Okay, so don't confuse with Lyapunov function. We don't have Lyapunov function here. This is Lyapunov exponent. Okay, so this definition is different. So just I show you now, because that is you understand.
Sir, actually, defining the function is very different or difficult. Assuming the function in Lyapunov.
No, I don't use Lyapunov function. Lyapunov theory is not work here. This is a Lyapunov. This I just show you that slide. We have now Lyapunov. This exponent. This definition is different.
Yes.
Okay. This is for both also continuous function and for discrete function both. Because when you have a derivative, this is a for continuous function, but this derivative you can discretize, like you do the Euler method. Okay, derivative change in the discrete form, and then you use this same formula. But this is a Lyapunov exponent, and this is not a Lyapunov function. So we in whole slide I have not used, never used in this whole lecture Lyapunov function.
Sir, differential equation, is there any analytical method are there, sir? Already shows Euler method, numerical method. Is there any analytical method are there, sir?
Yes. Actually, analytically it is not very easy. Okay, you can go through any book. Chaos and there is very book non-linear dynamics through Rajeshwari and some Springer. Okay, there are many books you can go through.
Sir, Rajeshekaran and Lakshmanan also there, sir.
Yes. That is very good book. Yes,
sir. Lakshmanan and Rajeshekaran.
Yes.
From Trichy, sir.
Yes.
Lakshmanan, sir, from Trichy.
Yes. But now little new books also available that recently published in last. This whole one book is already Lyapunov exponent, And there another book, Chaos and Fracture, Encounter with Chaos and Fracture. So there are many recent books also available.